In August 1992, South Florida represented one of the nation's fastest-growing metropolitan corridors. Dade County contained over 1.9 million residents distributed across coastal municipalities and inland suburban developments constructed primarily between 1970 and 1990. The region's building codes, updated following Hurricane Betsy in 1965, established wind-resistant standards for 120-mile-per-hour sustained winds. Most residential structures consisted of concrete block construction with engineered roof systems designed to withstand typical Atlantic hurricane forces. Late summer hurricane season was a recognized atmospheric pattern, monitored through National Hurricane Center protocols and local emergency management frameworks. South Florida's residential expansion in the 1970s and 1980s produced extensive single-family housing tracts across western Dade County. Homestead, Florida City, and Kendall represented major suburban developments containing thousands of concrete block homes with gable and hip roof configurations. Construction standards varied by development period, with pre-1980 structures built under earlier wind load specifications. Coastal zones from Miami Beach to Key Biscayne contained high-density residential towers and commercial infrastructure. The region's horizontal sprawl created continuous exposure across a 40-mile east-west corridor. Infrastructure networks, including electrical transmission, water distribution, and telecommunications, relied on above-ground systems vulnerable to wind-borne projectiles and structural loading. Hurricane Andrew formed as a tropical depression off the West African coast on August 16, 1992. The system tracked westward across the Atlantic, strengthening to hurricane status on August 22. Between August 22 and August 23, central pressure decreased from 983 millibars to 922 millibars within 24 hours. Maximum sustained winds reached 175 miles per hour, with gusts exceeding 200 miles per hour. The hurricane's compact structure concentrated extreme winds within a 25-mile radius of the eye wall. Atmospheric soundings indicated minimal wind shear and warm sea surface temperatures exceeding 85 degrees Fahrenheit. The storm maintained Category 5 intensity as it approached the Florida Peninsula on a west-northwest track. Forecast models projected landfall between Miami and Homestead during early morning hours of August 24. Hurricane Andrew made landfall near Homestead Air Force Base at 0505 UTC on August 24, 1992. The eye passed directly over southern Dade County with sustained winds of 165 miles per hour and central pressure of 922 millibars. The northern eye wall subjected Homestead, Florida City, and Naranja to maximum wind velocities for approximately 45 minutes. Eye passage created a temporary calm period lasting 20 to 30 minutes before southern eye wall winds resumed from the opposite direction. The compact wind field concentrated Category 5 forces within a narrow 20-mile swath. Communities north of the track experienced Category 3 conditions, while areas south of the eye wall received slightly reduced wind speeds. The storm's forward motion of 18 miles per hour limited rainfall accumulation but sustained destructive wind forces across the impact zone. Sustained winds exceeding 140 miles per hour generated horizontal wind pressures beyond design specifications for most residential structures. Roof systems experienced uplift forces of 40 to 60 pounds per square foot, exceeding connection capacities of standard nail patterns and metal straps. Wind-borne debris, including roof tiles, plywood sheathing, and structural lumber, became projectiles traveling at velocities sufficient to penetrate exterior walls. Gable-end walls suffered lateral loading that caused outward collapse when internal pressures equalized with exterior flow. Hip roofs demonstrated superior performance, but failed when sheathing separated from trusses. Progressive failure sequences initiated at roof-to-wall connections, followed by truss uplift, complete roof loss, and subsequent wall collapse under unbraced loading conditions. Approximately 25,000 homes in southern Dade County experienced total destruction, defined as complete loss of roof and major wall systems. An additional 101,000 homes sustained major damage, including partial roof loss, wall breaches, and structural frame compromise.
Entire subdivisions in Homestead, Florida City, and Country Walk exhibited uniform devastation, with 80% to 95% of structures rendered uninhabitable. Concrete block walls separated at mortar joints or toppled entirely when roof systems failed. Interior contents experienced saturation and wind scattering. Mobile home parks recorded near total loss, with units overturned or fragmented. Two-story homes showed differential damage patterns, with upper floors experiencing complete removal while ground floors remained partially intact.
The electrical distribution network serving southern Dade County suffered catastrophic failure. Transmission towers collapsed under wind loading, and wooden utility poles snapped at ground level or pulled from foundations. Approximately 1.4 million customers lost electrical service across the region. Substations experienced equipment damage from debris impact and structural failure. Water treatment and distribution systems lost pumping capacity due to power loss and facility damage. Telecommunications infrastructure, including central offices and transmission equipment, sustained direct wind and water damage. Road networks became impassable due to debris accumulation, downed power lines, and structural collapse of commercial buildings onto roadways. Traffic control systems ceased operation across the impact zone. Emergency response capacity degraded as fire stations, police facilities, and emergency operations centers sustained structural damage. Communication systems operating on commercial power and backup generators failed when fuel supplies became inaccessible. Hospitals in the impact zone evacuated or operated under emergency protocols with limited capacity. The scale of simultaneous structure collapse across a 200-square-mile area exceeded available rescue and medical response resources. Road access limitations prevented immediate deployment of external assistance. The concentration of damage within a defined corridor created distinct boundaries between devastated areas and functional zones, complicating resource allocation. Emergency shelter capacity proved insufficient for displaced populations, requiring rapid establishment of temporary facilities. Hurricane Andrew directly affected approximately 350,000 residents within the primary damage zone. The storm caused 65 direct and indirect fatalities in Florida and Louisiana. Over 175,000 people required temporary shelter in the immediate aftermath. Property damage estimates reached $27 billion in 1992 dollars, making Andrew the costliest natural disaster in U.S. history at that time. Approximately 600,000 people experienced some level of displacement or housing damage. The concentration of extreme wind forces within a narrow corridor produced casualty rates lower than wind velocities would suggest, attributed to landfall timing during early morning hours when most residents sheltered indoors and advance warning systems functioned effectively. Debris removal operations cleared an estimated 20 million cubic yards of structural material, vegetation, and household contents from the impact zone. Military engineering units deployed to establish debris staging areas and temporary road access. The absence of electrical power and water service rendered entire communities uninhabitable for weeks. Tent cities and temporary housing facilities accommodated displaced populations, while permanent housing stock remained under evaluation. FEMA deployed mobile homes and trailers to provide interim shelter. The concentration of damage created supply chain bottlenecks for construction materials, extending recovery timelines. Insurance claim processing overwhelmed available adjuster capacity, delaying damage assessments and reconstruction funding. Post-storm engineering analysis documented widespread failure of roof-to-wall connections, inadequate sheathing attachment, and insufficient bracing in gable end configurations. The National Hurricane Center classified Andrew as a Category 5 hurricane at landfall based on observed wind speeds and pressure readings. South Florida Building Code underwent comprehensive revision in 1994, establishing enhanced wind load requirements, improved connection specifications, and mandatory inspection protocols. The Federal Emergency Management Agency revised disaster response procedures based on lessons from Andrew's impact. The event established new benchmarks for hurricane damage potential in modern suburban environments and exposed limitations in existing construction standards.
Andrew's narrow damage path and extreme intensity provided data on structural performance under Category 5 wind loading, previously undocumented in contemporary U.S. building stock.